Today our lesson is going to be on the real number system. Now we've talked about a little bit of this before when we actually talked about whether a number was rational and whether it was an integer. But now we're going to take it a little bit further. We're going to decide first if it's rational or if it's irrational. And then if it is rational, we're going to take it further than just an integer into a whole number and also into a natural or counting number. So make sure you got the green sheet, the blue sheet, from the substitute to take notes on today. Alright, so on the side that says the real number system at the top, we're going to fill in these notes together. Alright, so the first thing is real numbers. Now, every number that you have ever come in contact with thus far in your mathematical career has been a real number. Every number that we will talk about in this 8th grade math class will be a real number. Okay, so there are imaginary numbers, but for now, real numbers, we're going to represent that with an R. Okay, so whenever you see an R. And for now, we're going to say that that is all numbers. Okay, all numbers that you are aware of right now would be considered real numbers. Okay, so that's any number that you know. So on these, whenever we're filling, when it's asking you to list all of the systems that a number belongs to, make sure that you put real numbers on every single one. Okay, now you can tell that from real numbers it drops down and it splits into two parts. On the left, we have irrational numbers, and on the right, we have rational numbers. Okay, so let's talk about irrational. Very important. Irrational numbers are decimals that never end and have no repeating pattern. So we call this non-terminating. That means that a number never ends. And then non-repeating means that a number does not ever repeat. Okay, so to signify an irrational number, we're just going to use a capital I. So I means irrational. Some examples of irrational numbers are pi. If you do that on your calculator, it's 3.14159, blah, blah, blah. It keeps going forever, so it never ends, and it never repeats. The pattern is never the same in pi. Okay, so any form of pi is going to be irrational. Also, square and cube roots that are not perfect, like the square root of 2. If you type that on your calculator, it's going to go all the way to the end, which means it's never going to end, okay? And then it's not going to repeat. None of the digits repeat in the square root of 2. Okay, the square root of 3 is also another example of an irrational number. The cube root of 5. Okay, if you type in the cube root of 5, that's also going to be irrational. It never ends, it never repeats. Now, if a number is irrational, then that's all it can be. Okay, real and irrational. There's nothing else that comes under irrational, so that's as far as I can go. Okay, so make sure if you say R and I, then there's nothing else you can put. You cannot tell me that it's irrational and it's an integer. It's not going to happen. Impossible. All right? If it's not irrational, then it's going to be rational. All fractions and decimals that end or have a repeated pattern are considered rational numbers. Okay, so remember, if it is just an integer like 2, I can write that as a fraction by doing 2 over 1. Now, we've already used an R for real numbers, so for rational numbers, we're going to use a Q. Okay, so rational numbers, some examples might be 1/2, 2, 3.5, the square root of 25, okay, because if you work out the square root of 25, you get 5, which is a rational number, okay? So just because you see that square or cube root, don't automatically assume that it's irrational. If you can actually work it out and simplify it to just a number, then use that number, okay? So for that case, it would be 5, and that would be a rational number. Now, if you determine that a number is rational, then it can go further, okay? The next step, if it is rational, we have to ask ourselves, can it be an integer, okay? An integer, we're not going to use I because we already used I for irrational. We are actually going to use a Z. So an integer has a z. It does not have a decimal. So examples would be -2, -1, 0, 1, 2, okay? Can be positive or negative, okay? But no decimal involved in an integer. So any number that doesn't have a decimal, positive, negative, or 0. Now, if it is an integer, then it's also rational and it is also real. If it's an integer, I've got to ask myself, could it be a whole number? In order for it to be a whole number, it has to be 0 or a positive integer. Okay? So, for this case, for whole number, we're going to use a W. Okay, so W for whole number. And this is going to start with 0 and go 1, 2, 3, so on and so forth. So only positive. Okay? A whole number is only positive. So if it is a whole number, it must also be an integer, also a rational number, also a real number. All right, and the last possibility is a natural number. Now, this is also called a counting number. So if you want to make yourself a note, this is also called a counting number. Now, natural numbers, we use an N to represent natural numbers. They are all the whole numbers except 0. When you start counting, you don't say, okay, I've got 0, 1, 2, 3, 4. No, you start with 1, right? So counting numbers start with 1, go all the way to infinity, just like you would count normally. So 1, 2, 3, ... Notice they're always positive because natural numbers come under whole numbers. We already said whole numbers have to be positive. Okay? So now we're going to look at some of these examples and go through how to identify if they are irrational or rational, if they are rational, if they are an integer, if they are a whole number, and if they are a counting number. All right, so let's look at that. 30. All right, we know that for these, they're always going to be a real number, so I'm going to start with an R. Now we have to ask ourselves, irrational or rational? Can only be one or the other, cannot be both. So since 30 does end, then we know that it is going to be rational. So I use a Q to represent rational. Now since it's rational, I ask myself, is it an integer? Well, does it have a decimal? No, it doesn't. So it is an integer. Remember, I use a Z to represent integer. Now, since it is an integer, I ask myself, is it a whole number? Since it is positive, then yes, it is a whole number. Okay? Now, since it's a whole number, I ask myself, is it a natural number? If I kept counting 1, 2, 3, 4, 5, 6, 7, I would eventually get to 30. So yes, it would also be a natural number. Okay, so that would be all of those on the right-hand side. All right, let's look at number 2, -11. This is a real number. They're all going to be real. It is also a rational number because it ends. It is an integer because it doesn't have a decimal. And that's as far as I can go. It is not a whole number because it's negative. And if it's not a whole number, then I can't say that it's a natural number. Okay, it would have to be a whole number to be able to be a natural number. All right, let's look at number 3. 5 4/7, always real. Rational or irrational. Since it's written as a fraction, 4/7, then I know it's going to be rational. So that's a Q. 5 4/7. However, that could be changed to a decimal, so it is not an integer. So just R and Q. Now let's jump down to number 8. Pi. 3.14159, blah, 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 goes on forever. It is a real number. It is an irrational number, so I use an I to represent that. Now, since it's irrational, I cannot even ask about any of the other classifications. It can only be real and irrational if it is an irrational number. Okay, I want you to go ahead and fill in 4, 5, 6, 7, and 9. Keep in mind that on 7 you can simplify. 6 divided by 3 is 3. So we're really talking about the number 3 right there. Okay. Also, keep in mind on number 9, it repeats. Okay, for it to be irrational, it cannot repeat and it cannot ever end. Now, although this doesn't ever end, it does repeat. So it is not going to be irrational, it's going to be rational. All right? Flip it over to the back side. Okay, we want to place the letter of each value in its location in the real number system below. So let's start with 7. Okay, A would be 7. Now, I know it's real, they're all real. It's not irrational. I know it's going to be rational. It is an integer, it is a whole number, and it is natural. So inside natural, I put an A. Notice that that A is in natural, it's in whole, it's in integer, it's in rational, and it's in real. So we want to put this in the most specific category that we can. Okay? Let's look down here at H, 0. 0 is rational. It is an integer. It is a whole number, but it is not a natural number. So I need to put H in the whole number section, okay? Remember, natural numbers are counting numbers. They start with 1. So 0 is not included in that, okay? Go ahead. I want you to see if you can put these values where they go using the letters, okay? Check them off as you go. Make sure you put them in the most specific. So even though 0 is also an integer, I put it in whole number because the whole number circle is inside the integer circle, which is inside the rational circle, okay? So that tells me that it is all of those. One more thing we need to go over is classifying whether numbers are greater than, less than, or equal to. If you don't know which one is which, this is greater than, less than, equal to. Okay, so if we've got a problem like this, 25%, we don't know what should go in the middle, and 3, okay, or let's say 0.3, actually. All right, so what you need to do for these is change them all to decimals. If you've forgotten that, look back at it. Changing 25% to a decimal, I move left 2 times. So I get 0.25. This is already a decimal of 0.3. 0.3 is actually greater than 0.25. So 0.25 is less than 0.3. You've got a couple of those to do on your classwork and homework. Now, for classwork, page 138, 2 through 8 even, that's only 4 problems. When you finish them, show them to the sub. She's going to check them for you, and then she will give you your homework. See you tomorrow.